6 reverse linked list. Given the head of a singularly list linked list, reverse the list and return the reverse list. So uh, this one or should be um, in reverse order, and pointing should also be pointed to the number before it. So the opposite pointing should also happen. So, for example, 1, 2, 3, 4, 5. It's not 5, 4, 3, 2, 1. And in this case, same concept. And this example, we don't have a head, so our output is nothing also. So let's how will we do this? Let's also we have a follow up to if we can do it iteratively and recursively. Let's start with our recursive, uh, iterative approach. Iterative approach. So let's name our head. No, our current equals to the head, and our previous equals to none. So while we have a current, let's, for example, over here, this is currently our head node, and this is our previous. So let's let's make a placeholder here for our feature current. A placeholder. Let's call it next node equals to current dot next. So so now we have this over here, and our previous is around here before the current. Let's let's make our current dot next equals to our previous. So now our current, this one will now point to this. So we'll now point to that. So now let's make our current, our previous equals to our current. So now previous will now be equals to our previous, sorry, this was our current over here, previous current. Our current when our previous will now be equal to this one over here, and our current will now be moved to here by this change, by this. Current is now equals to node next underscore node. So now this will be this because it was our placeholder, and return our previous. So now after this becomes our current, now this will be our previous, and now this will also point to this in the second iteration, and then now our current has already been assigned to this one is already our new node, next node, and so this one will become this, and now this one will now take its place here and point to this one, and so on until we no longer have a current value, and now we have a previous value. And let's run it and see how it goes. Yes, and it's been accepted. So this is our iterative approach. Now let's get to our recursive approach, which it seems somewhat easier for some people. This one is also easy, but so let's make our statements in case we don't have so over here it says it doesn't have a head, so let's make our base statement. So if there's no head, not head, and also let's make one just in case we don't have a head after. There's no need to. We have a next node after our head. Not head. Dot next. Return head. Okay. So now let's make our new node. New node. New head. Sorry, new head equals to self dot. I'll just copy and paste this. Our function name. Self dot head dot next. So after every value after our head will now be in this will now be reversed. So now let's make our head equals to none to now point to none. So okay, and now let's make the last value to be pointed to head dot next. Head dot next. So the next value, the last value before the head to be pointed to the head. So head dot next equals to head. Let me see if everything should go well. Okay, now let's return our return. Oops, that's outside the function. Return new head. So let me see. New head equals to. And that should work too. And that also works. And both of these are a time complexity of n. Both are time complexities of n. And that's it for this problem. I'll submit it and see if it works. And it works. And let me submit this one also and see if it works. The second one takes more space because it's a space complexity of O of n, and this one is space complexity of O1. And that one's faster, and that's it.